Hello, everyone. My name is John Mumm. I'm with the New Mexico Interstate Stream Commission as a water planner. Will kick this presentation off in a few minutes. We're going to allow more people to jump on. Hello, everyone. My name is John Mumm. I'm a water planner with the New Mexico Interstate Stream Commission. Today's presentation is on watersheds and habitat, on looking at the resiliency assessment initiation on this sector of use. And I'd like to introduce Hannah Risley-White, the ISC Deputy Director.
Good afternoon, everybody. I'm pleased to be with you for another one of these webinars. And I hope, I should say, Rolf Schmidt-Peterson isn't with us at the moment, but hopefully will be joining later. The purpose of today's discussion is to kick off thinking about resilience related to watersheds and habitat across the state. And so we have quite a few slides, but really we want this to be a discussion, and we're looking forward to hearing from all of you who are participating today, and thank you so much for being here. Before I get started, I also just want to acknowledge some of our other partners in this effort, and you'll see some logos here on the screen. New Mexico Bureau of Geology and Mineral Resources, the Water Resources Research Institute, New Mexico Water Dialogue, and New Mexico Indian Affairs Department have been very critical players to us in this effort. Also not shown on the screen here is U.S. Army Corps of Engineers. We have a planning assistance to the state's grant, which has allowed us to have quite a lot of support from them as well. And so just a shout out to those partners. I think, one of the downsides, we didn't get the resources that we had hoped to in some ways to work on this project, but in a way I see there's this silver lining in which that has really forced us to reach out to all kinds of expertise across the state to bring in thoughtful folks to contribute to this effort and get all the smart people at the table. And so we're really pleased to have these partnerships in place. I also need to give in particular a shout out to the folks at EMNERD's State Forestry Division, as well as some other folks from MNERD and NMED who have played an incredibly critical role for us in thinking through resilience assessment for this 50-year water plan, and in anticipation of this presentation today. And hopefully those partnerships will continue throughout the development of this plan into early next year. And then, of course, a thank you and shout out to everyone who's here today. And this is exactly what we're trying to do, is get folks together to think through these challenging issues to find solutions for New Mexico. And so with that, John, you want to go to the next slide, please? Okay, so this is just a little overview of what we're hoping to cover today. I imagine that many of you attended some of our webinars last week, and so a bunch of these slides will be the same. Sorry to bore you, maybe it's helpful to hear it again, I'm not sure. And then there will be other slides that are really specific to watersheds and habitat. And so essentially, I'm going to just do a quick overview of the 50-year plan itself, what we're trying to accomplish. Then we'll talk a little bit about what are the anticipated changes to our physical systems that we're seeing from the current projections. And that's included in this leap ahead analysis that the Bureau of Geology and Mineral Resources worked on. More on that shortly. And then some discussion of what are the specific impacts that are of most concern to watersheds and habitat across the state. Again, we'll have time for discussion. Then we'll talk through a little bit how we've thought and worked with our colleagues from our sister agencies in thinking through how to assess resilience specific to this sector, and then wrap up with additional discussion. So we want to make sure we have plenty of time for discussion here, and we're capturing everything we're hearing from you all. I should also say we did get some feedback from some folks that they wish that they could have seen this earlier and thought about it more before participating in this discussion. And I think, we're wanting to put this out today very much in draft form, but with an explanation for you all about how we got to this point. But then that's exactly what we want. We want you all to think about it, mull it over, and then provide us input. So next slide, John. All right, so I think it's helpful to just clarify what we're anticipating that the 50-year water plan will contain. And I want to stress that this is really distinct from any other planning effort that the state has undertaken previously. So as I think you all know, we are required by statute to work on regional plans with those regions across the state, as well as updating the state water plan every 5 years. And so that update to the state water plan will be due in 2023. This is distinct in that Governor Michelle Lujan Grisham really wanted us to focus on the specific impacts of climate change to New Mexico and thinking through, are we resilient? What are we prepared for those changes? Where are we least resilient and we need to pay attention? Where is there existing resilience that we can learn from and replicate elsewhere? So we're starting, and I'll talk more about the leap ahead, and we'll provide quite a bit of information from the leap ahead in this report. We're starting based on the governor's direction with a strong science foundation. So what does the science say specifically about anticipated changes to our landscape based on current climate projections? And then this discussion of resilience, which we're just sort of initiating right now, where we're resilient, where we're not, and then ultimately to provide recommendations for improved resilience. And so that could be anything from policy recommendations to adaptation strategies that could be implemented both at the local level and at the state level. So we're really hoping that this plan, the 50-year plan, I like to think of it as sort of like a spark that sets off some motors. So hopefully this will really light a fire under us to look for implementable, actionable recommendations that can come out of this report that we can all then run with. The report itself is not intended to be very long. We would originally talked about 30 to 50 pages. It probably will be hopefully not twice that, but maybe 50% more than that. It's hard to constrain it. But something that policymakers and others could pick up and pretty quickly get a snapshot of what we're looking at in terms of the challenges New Mexico faces related to climate change. The report will also then have supporting materials. So in the appendix, we can put a bunch of stuff. So we'll have, the leap ahead itself, and then the Water Resources Research Institute's New Mexico water budget, modeling incorporating leap ahead, and other materials. So hopefully there'll be lots there for folks who, if they want to dig in further, but also something that someone could pick up quickly and have an idea of what it is that we're confronting. I should also say just a little bit maybe about what the 50-year plan is not doing. So during the state planning process, we look at the supply-demand gap and we, project that out. This report is not doing that. It also is not, there is no new modeling or projections occurring for it. It's all using existing resources. So looking at what's the current science that's out there, what's the other work that's already occurred, and how can we synthesize that in a digestible way specific to New Mexico's water resources. So just to sort of clarify what it is and what it is not. Next slide, John. And then to give you all a sense of where we are in this timeline. So this process kicked off in February with our work with the New Mexico Bureau of Geology and Mineral Resources on, again, that sort of science foundation for this report, and more on that shortly. Right now, we're in this resilience assessment discussion. So really, taking that science foundation, but then looking at what are we seeing on the ground, and what does the expertise out there say in terms of where we're resilient and where we're not. And then between October and December, we're going to be working on, and actually probably really into January with the Water Dialogues annual meeting in January as like the last big pulse of public input to this plan on recommendations. So what is this plan going to recommend, and how that's going to be framed is still sort of under discussion, maybe short-term versus longer-term actions that need to occur. But that's what we're heading into this fall, with the idea that this plan would be finalized in March. And you all and we, as everybody says, we need more time for this, but this is just the time frame that we have to work with based on our directive from the governor. And so we're working hard to meet this timeline, and really appreciate all of the various players that are coming to the table to help us make that possible. Next slide, John. All right, and so as I mentioned earlier, we've had a series of webinars last week and this week on these different water use sectors, and I'm going to talk a little bit more about those sectors in a minute. But last week we went through agriculture and public water systems and domestic wells, both webinars similar to the one that you'll hear today, as well as sort of in-depth presentations from Amy Lewis, who's done a tremendous amount of work for us on this project, sort of thinking through resilience assessments. This week, today, we're covering watersheds and habitat. As I said earlier, tomorrow we'll talk about industrial, commercial mining, and power water uses. And then Thursday, recreation and quality of life. And we recognize that there's a lot of overlap in these different sectors, but really wanted to make sure nothing got lost. And so having the ability to talk about them individually seemed important. The goal here is to share with you all through these webinars, as I said earlier, our sort of current thinking, the brainstorming that's happened here at Interstate Stream Commission and together with some of our partners at other state agencies about how to think through assessing resilience in these different water use sectors, and then sharing that thinking with you all for your input and feedback. There'll be information at the end of this webinar about how to provide us that feedback, and obviously we'll be also engaging in discussion today and capturing your input today. Ideally, then the plan would be that mid-October we'd release some sort of final resilience assessment surveys for public and water sector use. So based on all this input that we've received, providing some ability for folks to participate in that, we'll then capture input through those assessment surveys that will be incorporated in the 50-year plan. So we're looking for your input today on how to assess resilience, and then with that input, we'll put out some surveys that people can use to assess resilience, and we'll capture that in the plan. Then in late October, there's the New Mexico Water Resources Research Institute's annual conference. Big thanks to those folks, because much of that conference will be dedicated to gathering input for 50-year plan as well. So we encourage you all to attend there. And then in early November, our partners at U.S. Army Corps of Engineers will be hosting workshops on sort of anticipated changes in New Mexico's climatic regions based on the current projections. There's a tentative tribal water summit in November. Thanks to the folks too at Indian Affairs Department for helping us think through some of that. And then, as I mentioned earlier, in January at the annual Water Dialogues Conference, we'll look forward to getting that last big pulse of input to capture in this plan. Next slide, please, John. Okay, so in thinking about how to evaluate our resilience, first I just want to say, in our exchanges with our state agency colleagues over the last few weeks, I've had the opportunity to hear a lot more about all the work that's occurred as a result of the governor's executive order on climate change, which established the Climate Change Task Force. Those folks have done a lot of thinking and work on resilience. And our intent here certainly is not to reinvent the wheel, but to promote and build on those efforts that have already been undertaken. And so that's again where we're really pleased to have had so much support in thinking through today's discussion with the folks at State Forestry. It's been incredibly helpful. So just to say, we recognize this is not the first effort at thinking about resilience in New Mexico. There's been a lot of work that's occurred already, and we're excited to fold that in and reflect that in the 50-year plan. But when we sat down and started thinking about what we're seeing coming out of the Leaperhead report, and again, more on that in a minute, and New Mexico's water resources specifically, it seemed like there's sort of two different ways to come at it, and we're wanting to do both here. So one of them is to look at resilience in terms of water use sectors, and that's where we've broken the discussion into the 5 sectors that I outlined in the previous slide, and that we're having a webinar on each of last week and this week. And then the other is to really look at the climatic regions across the state. So we're anticipating, different impacts based on those climatic regions. And the Leap Ahead report identified 4 climatic regions, which you can see on the map on your screen now, that will have sort of distinct, responses to the changes that we're seeing in climate. And so we're wanting to incorporate thinking along both of those lines. And I think when it comes to the water use sectors portion, it's been a challenging part of the discussion because there is so much overlap, and because water, of course, does not stick to any one sector. So in terms of, for example, in terms of watersheds and impacts to our watersheds from a changing climate, obviously that will impact every single sector. And so in the discussion last week, there certainly has been incorporated thinking around how these climatic changes are going to affect watersheds, which then impact public water supplies and agriculture. For this specific discussion today, we're wanting to think through not so much the impacts to ag and public water systems, but the impacts to our watersheds and habitats themselves, right? So it's hard to delineate these things, and inevitably, I'm sure in our discussion, things will get blurred. But the idea was to make sure that we covered everything. And by creating these different sectors, we were ensuring the discussion around our ecosystems and the impacts of those ecosystems wouldn't get left aside as we're talking about, our primary water users. And I should say, from the Office of the State Engineer perspective, in terms of tracking water use in New Mexico, 85% of water is used in public water systems and ag. And that's where we've focused a lot of our attention, Amy in particular, Amy Lewis, in terms of those assessments that we presented last week. But obviously, it is critical for us to be thinking about how these changes affect our watersheds and habitats in terms of those ecosystems. And that's what we're here to specifically talk with you all about today. And then, thinking through this resilience assessment and what the outcomes will be, we're wanting to align with the governor's goals of sustainability, equity, and stewardship. And then, as we head into the discussion about recommendations to include in this report, we're hopeful that this discussion of resilience will help us prioritize and develop, implementable strategies to achieve a goal of increased resilience in New Mexico. So next slide, John. Excellent. So on the leap ahead, and hopefully some of you maybe have already read the leap ahead. It's been posted on our website for, I'm not sure John could tell you, 2 weeks now. And we certainly are wanting to collect input on the leap ahead as well. I think one of the things that's really important to say right off the bat about the leap ahead is that the intent from our colleagues at the New Mexico Bureau of Geology and Mineral Resources was to capture current science, peer-reviewed science related to the impacts of climate change to our physical systems, or to our physical landscape. Their intent was not to then say, what does that mean for people? And necessarily not to say what that means for ecosystems. As they saw it, their mission was really to look at what are we expecting to see in the physical landscape. And so there's quite a bit of then translating what does that mean in terms of people and our ecosystems, and obviously there's exchanges back and forth between those, right? So I think there's two things that I've thought about a lot in this process so far and would love your all's thoughts on as well. First, there's how to talk about the uncertainty. And when you talk about climate change, there's a lot of uncertainty. And there's uncertainty in terms of the climate projections, but then there's also uncertainty in terms of the rippling effects of those. So, the effects that these folks evaluated to our physical landscape, how those impact ecosystems and people, and then in turn, the responses from ecosystems and people to those changes have additional impacts, right? So there's sort of cascading uncertainty in terms of impacts. And then the second thing that I thought about a lot is how to translate the science for decision makers and for lay people. You read this report, and so I sort of think, well, what does Joe Schmo in Albuquerque, like how does this affect him? So anyways, lots to think about there. I just wanted to right off the bat stress they saw their task as looking at what is the impact to our natural systems. Next slide, John. And when I say natural systems, I should say physical systems. So our partnership with Bureau of Geology and Mineral Resources resulted in them convening this panel of scientists. And as you'll see from the descriptions on the slide here of who those individuals are, they really are folks who focus on physical systems. There is Craig Allen, who's an ecologist, but the focus, like I said, has been really on sort of the impacts to our physical system. And these folks' goal was to look at all of the existing science out there and sort of synthesize it in a report that would then inform the development of the 50-year water plan. And so it's important also to stress, because there's been some confusion about this, that the leap ahead itself is not the 50-year water plan, but one of the many sources of expertise that is used to inform the 50-year plan. And again, we started here because of the governor's directive to start with a hard look at what's the science say about what to expect. And so the report, as I said, is on our website, along with the ability to comment on the report itself. In addition, we had webinars on each of the 12 chapters in the report, and those are recorded and posted on the website as well. And we certainly encourage you all to check out all of that information. Next slide, John. So what does this report say about what we should expect? It's a pretty daunting list of challenges that we're looking at here. So decreased runoff, and recharge due to increased aridity, decreased snowpack, earlier runoff, greater demands on groundwater as well as surface water, increased hotter, potentially longer droughts, stress on vegetation, increased forest fires, flooding and sediment transport issues, irreversible damage to soils, and degraded quality of surface water. So it's a little overwhelming reading this report and thinking through how we're going to prepare for the very dire changes that we're anticipating. Next slide. And given that, more important than ever for us to now urgently plan for resilience together. So in terms of what definition we're using when we talk about resilience, just to all be on the same page, obviously there's a lot of different definitions and we're open to feedback on this, but the definition that we've been operating with is the ability to anticipate, prepare for, and adapt to changing conditions and withstand, respond to, and recover rapidly from disruptions. And so the purpose of this resilience assessment is to think through, again, where are we resilient, where are we not, what do we need to do to prepare, and what is anticipated based on those sort of various climatic shocks depending on both climatic region and water use sector. And so this is where we're excited to have your input on how to do this, how to prepare together. Next slide, John. And to put it in context a little bit, I think some people say, well, how serious is this? Is this really as bad as that sounds? But if you look at the plot on this slide, so this is actual observed changes in temperature and precipitation between 1931 and 2020. It is clear when you look at that temperature plot that we are seeing temperatures rise. So this is very much real and has been for some time already. So in terms of precipitation, what you notice here is just more sort of variation, not a clear trend. But as we all know, if you have increasing temperature, you're going to have less water because you have more ET. So, and also, the climate models are showing more variability in terms of precipitation. So less predictable inputs to our system for us to plan around. And so, this is our new reality. And so we are definitely urgently in need to plan to tackle the challenges ahead so as to, ensure continuing economic development and the needs of all New Mexicans are met. Next slide, John. The next few slides that I'll cover before handing this off to John are out of the Leap Ahead report. And so just looking back, sort of thinking through what are we anticipating here, and the bottom line being increasing temperatures, and knowing that means that we're looking at a drier future. This map shows the projected change in temperature across the state. And as you'll see, it's a significant increase, especially in that northwest corner of New Mexico. And so, preparing for this is significant. Next slide, John. And of course, we're anticipating some significant changes across the United States. This map is interesting because it shows sort of the water stress index, which much of the eastern US is going to be stressed with too much water, yet most of the West looks like we'll have significantly less water. And one of the things that stands out to me on this map is just looking at New Mexico and the significant brown sections of the state there, and thinking through what does that mean in terms of what we're anticipating. Next slide, John. All right, and so as I mentioned earlier, higher temperatures are going to mean increased evapotranspiration across the state. And so this plot shows increase in potential evapotranspiration. So potential evapotranspiration is if there were sufficient water, how much water would evaporate from an open surface. And so we're looking here again at at significantly increased potential ET. Obviously in New Mexico, there often isn't unlimited water, so you don't actually lose as much as you might see on this plot, but that's because you've lost everything you have to lose. But this has a significant impact, say, on reservoir storage and how much water we'll be able to store in reservoir, but even more significantly agriculture, because of course as ET goes up, crop demands go up for water. And so this plot is also significant in terms of thinking through what these projections look like in terms of our water future. Next. And I should also say, in terms of our natural systems, watersheds and habitat as well. So this is significant. All right, sorry, John, go ahead, next slide. All right, and so again, in terms of increasing aridity, similarly, you'll see in the maps on the screen here on the left, there's a historical plot of an aridity index, which is defined as the ratio of potential ET to average precipitation. So those blue areas, you get more rain than you lose to ET, and then in the red areas, you have the potential to lose a lot more than you gain through precipitation. And the difference between the plot on the left and on the right is fairly remarkable. Plot on the right, or in the middle, I guess I should say, is the future projection. And you'll notice, again, significant increased aridity, particularly in the southern part of the state and in that northwest corner. The map on the far right then is the change in aridity index. And so there, the darkest areas are where we're anticipating the greatest change in aridity across the state. Next slide, John. And so in thinking through what this looks like in terms of watersheds and habitat, particularly riparian habitat or in-stream habitat, where those projections are showing the potential for significantly lower flows in our streams. If you look at the plot on the bottom and the high emission scenario in particular, we're looking at 50 to 60% less flow in our streams. And as you all know, many of our streams are already stressed or dried part of the year as it is. So this is a significant concern. Next slide, John. And so I'm going to hand this over to John now to cover the next bunch of slides that are really more specific on what we're here to talk about today, the watersheds and habitat piece. I also just want to highlight here, so the slides I just covered were out of the Leap Ahead report. So again, sort of focused on the impacts to our physical systems. The next bunch of slides, much of the information provided here is from the New Mexico Forest Action Plan. Again, big shout out to the folks at MNRD and their forestry division. That plan, if you haven't already seen it, I highly recommend you check it out. They've already done a lot of work and thinking in a much more complex way than we're doing here about resilience in our ecosystems, especially in our forest ecosystems. And so the work that you're about to see here largely comes from that. Again, no need for us to reinvent the wheel, but just promote and further the work that's already been done at MNRD. And so with that, I'll go ahead and hand it over to John.
Thank you. Again, yeah, a lot of the next maps and information is out of the Forest Action Plan or other pieces that are looking more at our current situation, not projections as much. But what we're looking at here is ecosystem vulnerability to the climate change. And it kind of depicts where the climate change poses the greatest risks to our ecosystems, and how, just looking at that, where that vulnerability might be an issue, especially in our riparian zones and ecosystems along watersheds. Here's a look into the wildfire hazard, again from the Forest Action Plan. Wildfire hazard is, again, a function of burn probability and conditional fire intensity. The burn probability is the likelihood a fire will start or spread, and the intensity is the probability of a fire burning at a given intensity. And so this is a look at that kind of vulnerability throughout the state as we look into the next, as climate change is coming along. Again, this is looking at over the last 20 years of areas burned over those 20 years, and it's quite a large amount, again, with the probability of forest fires and aridity increasing. It's something to consider as we talk about vulnerability of our watersheds and habitat. As we talk about kind of especially streams and conditions, we want to hit on erosion susceptibility and also post-fire erosion hazards as you burn the forests and vegetation. You're going to damage those soils and it could create even more susceptible erosion. Again, the map on the left just shows erosion susceptibility by the slope and soil erodibility, and the one on the right is on the post-fire erosion hazard of if those fires happening, creating and damaging those soils, making it more erosion. And so the big thing to think about that as we look into the resilience concept is that erosion causing sediment loads in the riverways, making it hard to use. This is a look at habitat for species of concern. This is out of the Forest Action Plan. Again, this looks into the habitat rank of sensitive species and crucial habitats that are risk throughout the state, and it really looks into the habitats that are species of concern, especially terrestrial. And again, as we think about the water availability for the our watersheds and habitat, not only just the streams themselves, but for in the bosque and riparian zones, we really are looking at decrease the surface waters. And so what does that mean, and how is that going to affect the ability to care for the these critical habitats? And so again, surface water discharges, we're seeing a decrease, due to the snowpack, decrease of runoff and drought. And so this one is actually from the leap ahead, but it's to think about that concept with the risks and vulnerabilities of the last few maps, looking, if we have a decrease in stream flow also, what does that mean? This slide kind of looks into the climate resilience of biodiversity. Again, with the concept of this is to kind of look how your landscapes along, especially streams and within watersheds, the terrestrial landscapes, that their capacity to support the biodiversity, your biological productivity and ecological function, to even to climatic and species change over time, its ability to support kind of a stronger biodiversity. If it's important to the habitat and kind of the riparian zone of the watersheds to have the ability to handle that a biologic productivity and ecological function to handle those changes. And so this is kind of just a look into the areas throughout the state that are resilient to these changes in biodiversity. Again, from the Forest Action Plan, it's a great map on that concept. Again, areas that have riparian corridors that help with watershed health. As you can see, a lot of them are along our major streams, the Pecos, San Juan, and Rio Grande. And again, those are just kind of a look at kind of the changes that we're looking at, vulnerabilities that are coming. And so I'm going to have a poll. Again, this is a discussion section. So I'm going to put the poll up right now. And I hope everybody jumps on and is able to jump on and take it. You're allowed to answer as many as you want. Again, what it says, the question is how vulnerable do you think you are to changes that are coming, especially in watersheds and habitat sector, thinking of where you're locally at. All right. So our results are 43% say we're extremely vulnerable, 51% very vulnerable, and 14% say somewhat vulnerable. Just to start a discussion, if anybody that thinks somewhat vulnerable, what was your reasoning, or extremely vulnerable, your reasoning behind that? And feel free to unmute yourselves.
I'm just going to say, John, so John and I can watch these results come in. I don't think you all can see it, but it was interesting because initially the people who very first responded said extremely vulnerable. But then as more people responded, very vulnerable ended up with more votes than extremely vulnerable. But yes, it looks like Kurt Anderson.
Yes. I live below Elephant Butte Reservoir. We live below Elephant Butte Reservoir. And I consider us as extremely vulnerable simply because of the decline in flow in the Rio Grande River during irrigation season, because that also is essentially the only source of recharge for our major aquifer. My main concern is that we're going to run out of groundwater as well as surface water on a time scale of about 50 or 60 years.
Thank you for that, Kurt.
Kurt,
John?
There were some questions submitted earlier as we were presenting. One was a comment of add irreversible damage to aquifers attendant upon subsidence. And then what role does the Bureau of Rec play in this exercise, Elephant Butte Irrigation District, and what control does the state have over waters of the Rio Grande? Is that something that you could possibly answer, Hannah?
Let's see. So there's a number of questions there from Kurt Anderson. What does Bureau of Reclamation play in this exercise? You know, I think that we're looking to all of our partners across the state to provide input. Bureau of Reclamation doesn't have a specific role in this 50-year water plan, but we certainly would welcome their thoughts as we're gathering input. So I just leave it at that. And same thing with Elephant Butte Irrigation District. We're really encouraging everyone to participate here. In terms of what control does the state have over waters of the Rio Grande, you know, obviously our colleagues at the Office of the State Engineer play an administrative role in terms of ensuring state regulations are met and enforced. And then at Interstate Stream Commission, we have a role in, you know, providing guidance with regard to New Mexico's compliance to our interstate compacts, particularly from a technical perspective, providing guidance to our Rio Grande Compact Commissioner. And so that's how I would answer that question. But I certainly, if there's any of my colleagues who are on who want to jump in on that as well, I'd welcome them to do so. And then I guess I wonder, you know, sorry, go ahead. If any
sorry, Hannah, this is Grace Haggerty. Yeah, I think that was a good answer for those two questions.
Thanks, Grace. And I appreciate Grace and Trevor Burt from our Rio Grande Bureau who are on today specifically because of their role with regard to New Mexico's compliance with Endangered Species Act requirements, which is obviously a significant consideration, as well as we're thinking about impacts to watersheds and habitat. And that's where I'd welcome anyone else who's on so far who wants to chime in with regard to sort of vulnerabilities and what your main concerns are specific to watersheds and habitat. If there's any folks who want to chime in on that. Okay, well, I think, you know, John, we could move on because we have additional discussion section later in this presentation.
Yep.
John's going to now go through sort of the thinking around assessing vulnerability specific to this water use sector. And then we'll share with you a matrix that we've been working on together with MNERD and NMED and others, and we'd love your input on it. So maybe with that.
Hi, this is Paul Montoya, and I'd like to make a quick comment here on that previous question. And that is, we live in Farmington, which is in the northwest corner of the state. And I'm sure everybody has read about the Gold King mine spill and how something when that gets away from us in a hurry, we are very vulnerable because we get in fact, we get all of our water out of the Animas River. So when that becomes polluted, we're suddenly shut off from our water supply. And fortunately, we had a lot of storage. So if we don't have storage, we're in big time trouble. So that's what I wanted to comment on. Please go ahead.
Thank you for that, Paul. And yeah, I think that is certainly a concern. And I should say, in talking with our colleagues from the MNERD's mining and mineral division, we're thinking through, like, you know, if vulnerabilities related to exactly what you're talking about, if we're having the potential for, it's not quite a Gold King, but, you know, large storm events, are our watersheds protected if they have mines in them that have the potential to have contamination issues, given, you know, circumstances where there's flooding? There's lots to think about there.
Well, it's circumstances beyond our control. For an example, it doesn't necessarily have to be a Gold King mine spill. It can be a railroad tanker full of XYZ chemicals that can pollute an entire watershed in a short period of time. So I guess my point was trying to be is something that happens outside your watershed that you don't really have control over, that you're going to be big time impacted by. And fires are another example of that too. You know, you don't necessarily have to have a fire in your watershed to be impacted by runoff and stuff like that. For example, like Santa Fe, 4 or 5 years ago, had those big runoffs in their watershed that contaminated a lot of water area. Thank you.
Absolutely. Thank you for that, Paul. Certainly a concern.
Paul, I see your mic is on.
Oh, yes. What can I help you with?
It's another Paul.
Oh, I'm sorry.
Oh, yeah, it's Paul Tashin. Do you have something you want to chime in? Maybe not. Well, let's,
Good.
John, why don't you move on and we'll come back to, we'll have more discussion after the next set of slides.
Sounds good. All right, we're gonna kind of jump into the concept of resilience again as we look at watersheds and habitat. Again, a great thank you to the other state agencies that helped us, you know, kind of go over these ideas because they're pretty complex in their own. Again, resilience improved for watersheds and habitat are through terrestrial conditions, biotic condition of stream, abiotic conditions, kind of abiotic conditions that, you know, are there, such as slope, water availability. With biotic are things that are easier to manage and changeable. We have watershed health from forests, riparian, and rangeland conditions along within our watersheds, and then management ability, our ability to set up terrestrial treatment plans, conservation districts, conservation plans, drought management plans for species and the environment in our watersheds. Again, a way to look at it is something as we kind of go through these ideas, and we'll get to the matrix later, is how, you know, to look at whether resiliency is there. And one is on fire risk and fire regime, you know, combine wildfire risk to critical habitat for terrestrial threatened and endangered species. That's what this map looks at. There's a large intact area, blocks of habitat or important plant areas, habitat connectivity, or your riparian corridors, and that. So this is kind of looking at that, the risk of those wildfires and that biodiversity that would greatly affect our watersheds and habitat along them. And then looking at watershed health as it impacts water users and the habitat there. You look at the erosivity risk index and looking at how that sediment where is it extremely severe risk area and where is it not along our streams in that habitat. Again, post-fire erosion risk, where is this most significant? Where is it not? How is that going to affect whether you're resilient or not for a watershed and habitat resilience? How can these areas that are very severely at risk, with the resilience, how are they less resilient than the areas that don't have those issues of post-fire erosion at risk? Some areas to look into is stress indicators for your riparian health. Again, this is from the EPA recovery potential screening. Again, this covers quite a bit of area on those sections. Again, on our matrix, we do hit on different EPA plans and plans that you can look into to kind of identify these resiliency issues on as a watershed or habitat view. Some examples, severity of loading, stressor persistence, elevation, water use intensity, hydrologic alteration. Again, this covers a lot of stress indicators for your riparian health along a stream or a lake. So just to kind of go over some stress indicators of that riparian health. Again, your stream condition, this is kind of looking at stream temperatures, where you're going to have impaired streams and lakes by the increased temperatures throughout our stream conditions within the state. And stream temperature is quite an issue for species, species that are aquatic, and how is that going to affect even with water quality and the ability for vegetation also. So this is kind of looking at that impaired streams by that concept. Again, river system conditions to all the potential changes and how these changes are going to interact over the next 50 years into the future it may be very difficult to accurately assess it, but it's to kind of look into the concept, how these changes include, but not only limited to, rates and volumes of that stream flow. Again, changes in timing and temperature of that stream flow, especially for species that need a colder water. Changes in river sediment regime. How does the stream move its existing sediment under the above conditions? How much will that sediment load increase due to the climate change? By that, what we've kind of hit on, the risk of erosion, the risk of the post-fire erosion issues. Where does that sediment go? How is it going to go, into reservoirs or lake? How is that going to affect that environment? And where does that increase erosion mean for stream beds, down cutting in some areas, filling in others? What we kind of touched on, the temperature above, how is that going to affect that? Are these changes consistent across all areas of the state or not? And these are some just general ideas to think about as we talk about these river system conditions and stream conditions, even in the matrices later on. Again, riparian health. This is from New Mexico Non-Point Source Management Program and a report, and this looks at the riparian health along streams, and so where is it most healthy and where is it not? And so just to have a general idea of riparian zones and that being a very important part of our watershed health and habitat within our watersheds. And then also the kind of concept of land management use, where on throughout our streams is, you know, kind of the land management, where is it, are we able to do things through government agencies, but also management through conservation districts. And so what are the land uses going on within our watersheds? How does that affect the habitat and the watershed itself? And looking at are we even able to make large changes in some of those habitats? Because if it's in a specific area, the management might be on private land. So how do we convince the owners and users of that land use to consider the habitat and the watershed health? So these are things to kind of think about that resiliency. And again, storage, especially for managing the temperatures and managing with sediment loading and just managing water availability, looking at where raw water storage is for drinking water supply, you know, fish and wildlife, flood control, and areas to where these locations are throughout our state. And then again, a big piece is administration, land and water agencies, entities, and owners. How are they going to function to make sure that we are able to make sure that our watersheds and habitat are resilient? Having watershed associations, agencies, and NGO support, terrestrial treatment plans, species and habitat of concern management, and having plans out so that we can make sure that these ideas are resilient to the changes coming. And so it's having that ability for administration and management a lot within our watersheds and habitat along our streams and lakes, that we have the ability to manage it so that the health of the watershed and habitat is resilient to these things. And so these are some pieces that will help with that as we go into a more frequent drought and drier environment. This is our resilience matrix. Again, there's a lot of pieces that can fit into parts of this matrix as parameters. Again, this is a draft. This is where we want to have a discussion. Again, we touched on fire regime, kind of the forest structure and composition, our stream conditions, riparian status of these watersheds and habitats. What is the land use going on? How is the landscapes managed? And then plant water availability, the availability of water, and then what is the risk of erosion? So these are kind of a piece. Again, on the right-hand side, we have additional resources that you can look into to see if your watershed or the habitat along it is touched. So let me get up a quick poll, and then we'll start a discussion on this matrix.
Maybe, John, when you put the poll up, can people still see what's on the screen? I'm sorry, I'm asking this question on this live webinar. Just wonder if people need a few minutes to look at this before they answer the full question. The idea here is sort of to capture in one place in this matrix all of the considerations that should be considered as we're looking at resilience of watersheds and habitat. And again, big thanks to partners at MNRD and NMED in helping us think this through. But we'd love it if everyone here can take a good look at this. And also, as I said earlier, this material will be posted on our website. So if you need to sort of mull it over and digest it and then provide additional input, we certainly encourage you to do that. I think if you want to launch the poll, John, you can, and then we can always leave this slide up to have discussion while we're looking at it.
Absolutely. Absolutely.
Thank you.
So I'm launching the poll. Question is, how well do you think this matrix captures necessary considerations related to the resilience of watersheds and habitat? All right. So we have 30% that said very well it captures it, 67% say somewhat well, and 4% say not well. So I think to start a discussion on the matrices and what issues with it and how could it be improved, I want to reach out to the not well, how they voted on that, and then even the ones that said very well to start this discussion.
Hey, this is Paul Tashin. Can you hear me now?
Yes. Hi, Paul.
Yay, my mic works. Great. Okay. I was wondering,
Yay.
I actually said very well. I think it's a really nice matrix, and I'm really pleased with this talk today. My only thought is that this stream condition, you sort of lumped the physical habitat with the flows, and it may be useful, there's benefits to doing that as well. But the whole issue of what is in-stream flow and how you define environmental flow, I think is really important. So it may be useful to split those out into like physical stream condition and then flow needs. And the reason being is that, in-stream flow isn't just blanketed water for all rivers. It's really understanding the systems and understanding what are the key components. So if you, and just quickly, and then I'll jump off, but if you look at the Middle Rio Grande, it's drying, it's intermittent, but it's still got resilience, all right? And not that it's not vulnerable, but there's still resilience because there's still a spring pulse moving through. There's still some stuff happening. So just in that light. So just that, my only suggestion is maybe splitting that out, physical and flow. But you could also lump it, but just as long as the in-stream flow part is elaborated on and understood.
Yeah, I see your point, Paul, that you could have different resilience in those as separate sort of indicators. So yeah, that's an interesting thought. I wonder, before we move on, if anyone here has any response to the comment that Paul just made. And you can just jump in.
Hello, Anna. Oh, go ahead. I'm sorry.
Go ahead.
All right. Yeah, this is Patrick McCarthy, and I just put into the chat a couple of comments that kind of reinforce and maybe repeat using different words what Paul was just saying, especially separating physical structure of the river from the river processes, including flow and sediment regime, because otherwise there's just too much packed into that number 3, that parameter of stream condition, that it's trying to capture and understand too much. And I don't think it could be readily measured, the resilience that is, because it's just too, there's too much there. It's like saying forest condition.
Right. Yeah, fair enough. Thanks, Patrick, and thanks for your comment in the question box. And then someone else was going to chime in on this discussion item as well.
Yeah, this is Toner Mitchell with Trout Unlimited. I want to kind of add something to Patrick and Paul. One thing that might be improved a little bit, I really appreciate that you address stream condition vis-a-vis sediment. One thing that concerns me from a trout and riparian species standpoint is that we're not getting the runoff to scour winter habitat. So we're getting a lot of pool habitat being filled in by bigger material during something like a small flood, but a sustained runoff would act to scour things and deposit sediment and enables streams to repair themselves. Right now, our resilience, I think, is a little bit diminished by historic, I guess, destruction of streams structurally. So we've got a lot of legacy channeling, and we have a lot of sediment inflow previous to climate change. And so over time, the streams have gotten wider, and I'm concerned. I like the leap ahead when we talked about erosion and stuff, but I think we're getting streams that are switching from gaining streams to losing streams higher and higher in the systems. I don't have any science on that, but it seems to be the case because a lot of streams are filling in their pool habitat, becoming very homogeneous in terms of stream depth, which makes temperature change that much more impactful. So there are a lot of things, that are affecting that. And so if that could be reflected, I think with the in-stream flow and what Paul was saying, that would make this an even better matrix.
Thank you, Toner. That's very helpful. Do others have any follow-up comments, especially now with some of these additional thoughts that Toner just added?
This
Kurt
is
Anderson again. Kurt Anderson again. If I was filling out this matrix for the lower Rio Grande, I'd have to put down not applicable for most of those 8 items. They simply don't apply in terms of the lower Rio Grande, which frankly is bone dry for most of the year. The only tributary to the lower Rio Grande, if you look at a list between Elephant Butte and Texas, is the Rincon Arroyo, which occasionally floods and dumps some sediment into the Rio Grande. But, the Rio down here is one big channel, which doesn't interact with much of the rest of the world. There's nothing that resembles a riparian area, really. And quite frankly, the only what I would call riparian areas are areas that are watered by the outputs of wastewater treatment plants, principally Las Cruces. In other words, most of these parameters don't apply. Sorry about that. End of comment.
Yeah, I mean, I think your point is well taken. It's hard to think about resilience for habitats where there really isn't any habitat now. So, yeah, thank you for that, Kurt. And then it looked like maybe Jennifer had something to say.
Yeah, this is Jennifer Fulham, and I think it just adds on to some of what everybody is saying as far as stream condition. Stream condition and resiliency is really dependent on the hydrology and what that system is intended to support. And ephemeral and intermittents and perennials all support different ecosystems, and the resiliency comes in their functionality to support that ecosystem specific to their type of hydrology. So kind of splitting it out a little bit, even more so based on hydrology, and then, so not just stream flow and the stream condition, but also each of the different hydrology should be considered independently of each other to really understand whether they're resilient or not. We want ephemerals to flow hard and fast during a storm event. We don't necessarily want all that deposition in our larger perennials. So they have different levels. They're bringing different stuff to the table and maybe be considered independently of each other.
Yeah, good point. It's been tricky to, create something simple when we're not dealing with a simple problem. And so, yeah, I think that point is well taken as well. I know John and I are seeing a bunch of questions come in the question box as well. Did someone else want to jump on this particular line of discussion while we're going on that?
This is Grace Haggerty with the ISC, and one thing just looking at the parameters maybe to think about is, because I see forest structure and composition, maybe just overall, like, is there room for kind of evaluation of species diversity or something like that would kind of look at these watersheds and whether it's plants or animals to kind of then utilize that to kind of determine how resilient or non-resilient right now you're at, as in the lower Rio Grande. We know it's basically, maybe it's our touchstone for what is not, maybe it's highly resilient because there's nothing there right now to damage it anymore. But yeah, so I was just thinking along those lines. I know you're looking at physical parameters, but I know with the forest, you're looking at plants, you know, overall, you might want to think about that. You know, all of these things are resilient for what? You know, are they resilient for your biology that are dependent on it, or, you know, what? So I do think that there's room for a few more lines in this evaluation or this matrix. Does that make sense, Hannah, at all, or John, or anybody else?
Yeah, I think that's a good point, Grace. There's a lot that needs to be considered when we're thinking about resilience, and certainly species diversity might be part of that. It's hard to know what that looks like. We're gonna have to do some good digesting of all of this. Has been really fruitful discussion so far of like how to tweak this based on what we're hearing from folks. But yes, thank you.
Hello, this is Lori Wiyaki, and I'm looking at this from kind of a lay person's perspective, and I'm wondering, like, would it be possible, or is it too cumbersome, but to go through these like draft parameters and almost provide like a picture of what lower resilience looks like versus higher resilience, and not necessarily for each one, but just sort of helping people to picture what the differences look like, what they are, to the previous person's point of like resilience for what, for whom, right? And to me, I'm looking at this from like resilience for us here in our current lives, but also in the generations yet to come. So I kind of understood that this process or these resilience matrices are in fact to try to help the, you know, lay person out and about in the world to begin to care a bit more about our resiliency. And so I just think it's just a suggestion. Thank you.
Thanks, Lori. And I think that's a good point that you raise in terms of, and this has come up already a number of times in our discussion, thinking through this assessment, is like, who is the potential end user of these matrices, right? And so, you know, ideally we'd love it if it's something that folks with expertise in these fields are looking at and using. But certainly also, as you just said, something that someone who hasn't really thought about this before could look at and learn from, and then, you know, observe in their local communities sort of these parameters, and sort of start people thinking about it who are folks who haven't been thinking about it before. And it's a little bit of all of the above, but then that also makes it it challenging to make something that's accessible for folks with various levels of expertise. John, do you want to go to some of the questions in the question box?
And I wanted, Lori's, a lot of the additional resources are there on the far right column for looking into that information of whether, when you talk about fire regime, you can look at the maps and the information that's in the Forest Action Plan, the New Mexico Climate Risk.org. That was the goal of that information. Is we don't have, the ISC doesn't have a data set for all this. It's such a widespread idea. So, you know, if it was just on water, you know, water availability and stuff, and that was it, kind of what we hit on in the ag and in the public water systems, we have data like that. For watersheds and habitat, we don't really have the data, and so we want to make sure there's information for people to go on these different parameters and go to areas that have that information for you to look at. And so that was the goal for that. But let me hit some of these questions that are coming in. River system conditions, does river seepage play a part? Let's see. I believe so. I think, you know, I don't see why it wouldn't. I think, again, as people were touching on, you know, finding a way to separate the concepts into two categories or two parameters, I think would address that seepage part more. Hannah, do you have any addition to that?
No. I mean, I think that some of Toner's comments too were getting at, you know, what happens as our river systems change. And I think one of the big things that I thought about with the leap ahead is just there's a lot of discussion about erosion or sediment loss or transport, and wondering where that's all going to end up, and you know what the potential implications are of that. And it seems pretty significant in terms of affecting how our stream systems function. Back to Jennifer's point about the hydrology.
Here's a comment. There is Copper Flats mine as a concern for polluting the lower Rio Grande. And the next question would be, is water quality included in stream condition? Where are the special status species? And that is something that was brought up in that earlier discussion. I think as a hit on, those should be addressed within possibly separating stream condition into different categories of what it is, being one, because it's such a big lumped area. And with water quality, probably there's different parts of it, I think, throughout this that you could put water quality in different locations with, but it, you know, it's where would it fit properly? And I think that's where we're looking for suggestions on something like that. Another comment, another factor for stream condition likely should include temperature also. I think that would be actually a good consideration.
And then I think, because we talked about this a little bit, it's similar also to Jennifer's comment about hydrology. Obviously, that will be more or less of a concern depending on the specific stream system and the temperature requirements of the species in that system. But clearly looking at rising temperatures across the state, it's going to be a factor in many stream systems.
Some other comments, and some of these were coming out as we were through the discussion, so you know, maybe one of the parameters could be flow regime, although even this is complicated because of water supply management and MFRLs. So I think that was discussed during that, how, you know, with the hydrology, you know, it's a complicated one to touch on. And then they hit on sustained base flows might be a consideration. For water availability.
Right, and I think that that's also where, you know, there, again, back to what I was saying earlier about uncertainty. I mean, I think there's definitely concern here about sustained base flows for sure, and some uncertainty in terms of, you know, needing to have more data and understanding of our stream connected aquifers across the state so that we can anticipate better what the, you know, potential impacts to the base flows will be given the changes that we're seeing. And on any of these, if folks on the line want to jump in and comment, we certainly welcome you to do that.
There's a question here. I don't see any of the listed resilience measurements being something we can improve in any meaningful way. Am I missing something? I think that the goal of looking at the resiliency is a lot of it matters on how the landscapes are managed, and also the availability of water and land use part. Some of these things like the soil erosion is seeing that issue and how are we going to deal with that situation is a big piece of especially habitat and the watershed itself. Is some of these things are physical things that need to be managed in a specific way or looked into. Just seeing where the watershed and its habitat is actually, you know, vulnerable to these changes, and they're going to get worse. I think that's a big piece of what this matrix is looking at. Do you have anything to add to that, Hannah?
Yeah, I mean, I would just say to Bob on that one, I think that, you know, definitely echoing what John just said, land use, you know, our land use practices are very significant here. And how landscapes are managed and how riparian areas are managed and how our flow regimes are managed. Many of our rivers, you know, flow for species is dictated by reservoir releases, or for example, in the Pecos Interstate Stream Commission has our pond conservation pipeline, which pumps groundwater to keep enough water in the river for the Pecos Bluntnose Shiner. So I think all of those things have the potential for us to improve in a meaningful way how we're managing these systems with very consequential impacts. So some of these, you're right, are just purely reflecting the physical system, but some of them are very much entwined with humans' interactions with this landscape. And so I hope that certainly what might come out of this discussion is some recommendations for how to manage these spaces in a meaningful way to improve their resilience, especially because of not only for their own sakes, but the impacts that these systems have on all of the other water use sectors, as we were talking about earlier. But I certainly would also encourage you, Bob Wesley, if you have further thoughts on that or want to send us additional input through the survey that we'll have related to this matrix in terms of how to make it more clear what, you know, what the decision points are for future action, that I would encourage you to do that.
Here's some good comments here. Species richness and diversity is a good parameter, whether in stream or upland also would help with soil erosivity, and since more plant structures are able to minimize erosion. Those are both good points on that. Let's see. This is from some data. You mentioned NGOs in an earlier slide, but not in this matrix. I think that's where it comes to how landscapes are managed. It might be something to consider of how to word that resiliency piece. How that management, how something like an NGO could have the ability of support for a watershed association. I think that would be one of the parameters of the wording is there, but might be a suggestion to add to that of how that's where that could go in that to make it more clear. Is there any comments as we're going through these comments and questions from anybody?
Hey, John, this is Grace Haggerty again. You know, I kind of had the same question, I think, when it came to water systems, is it feels like the definition and the sizes are really important in looking at these watersheds. Like if you take the Pecos watershed or the Rio Grande watershed, you know, there's so many different components of that. And I definitely think when people think watershed, they think, you know, the areas that rain falls a lot and provides, you know, water to the streams and things like that. You know, and that's why fire management and forest structure and those sorts of things are kind of at the top of this list. And I'm wondering, sort of, have you defined like what you want to say is a watershed? Is it the basin? Is it you know, is it smaller watersheds within? I mean, have you mapped everything? Is everything mapped out that would then allow people to kind of look at those watersheds and put the matrix to the test as far as resiliency?
I would just say, I can jump in, John, that, you know, we haven't mapped this out in terms of, hey, look at this one specific watershed, or if you're in, you know, Santa Fe, you should look at the Santa Fe River watershed as opposed to the Rio Grande, the entire Rio Grande basin. So I think that's a, that's a good thought. Like, what is it that we're evaluating with this matrix? And, you know, maybe some guidance needs, something for us to think about. Maybe some guidance needs to be provided along those lines. I think we were thinking that we were, you know, creating a tool that people could use for whatever system they were particularly concerned about. So whether that was a small or a large one. And I guess the larger it is, the harder it is to use this tool because it might just have so much variation within it, right? So I don't know, something to think about.
Right. It is, the Forest Action Plan does have a map that ranks watersheds.
Okay.
And again, that's some of the additional resources it places before not knowing what we hit on is stuff that is measured out. The ISC doesn't, you know, we don't collect terrestrial, you know, information like that. So you work for the ISC yourself. So, I mean, that's the kind of pieces that we need to look into if we're going to talk about, for, you know, the riparian health, species, and these are some suggestions of where that data is, and that's what we're hoping too is some of these, such as the stream condition, is such a broad piece. How can we break that so it's more successful at seeing if where your watershed is it resilient? What is this watershed? Again, that can be found in some of this in the Forest Action Plan. How they define watershed might be different. Again, if we start breaking it down into smaller, it might be slightly different. So it's something to, again, consider. There's thought of, you know, in the future, you know, producing some kind of tool that would take all these different sectors and measure it so you could look at where you are in a location, but that would include agriculture and things like that, of whether you're resilient. but the 50-year water plan, we don't have the time or resources to do that, you know, in time to have something that you could jump online and easily see whether that is. I do know that the Forest Action Plan does have those maps. They have quite
Right.
the amount of maps that look into that. And so it's definitely a place that, and we were really thankful for their help on kind of thinking about how to look at this. So I would definitely look into that. Again, EPA has a watershed index and different places, but it's something that I don't know, because each group might or agency might have a slightly different definition of the size of what that watershed is.
Right. Yeah, slightly. Yeah. Yeah, no, I think that's really good to note that the Forest Action Plan and some of these others, I know NMBD looks at watersheds particularly, but I think that connection is one that probably the IC hasn't really used much before, like, you know, how important the forest health is to getting water into the streams for all the different uses. So I think it's definitely, you know, we could probably do a much higher level and just connect through, you know, these different agencies that do more, and NGOs that do so much more work within that watershed. But I was just kind of curious how the 50-year plan was kind of trying to look at habitat health and forest health, watershed health in general.
I think the big goal was not to exclude it. That was the big piece, because it's such an important part, especially to improve resiliency for, you know, water availability and all these other pieces that want to make sure that we didn't. And that's why a big piece why we kind of separated the sectors, so we could focus specifically, look into these pieces and not coast by it with just things that have, you know, like water rights, or just stuff that you know, that we can measure as an agency, what the ISC looks into. And so I think that was a big reason why we separated the sectors, so we don't coast by something as important as, you know, the watersheds and habitat health throughout the state. And the hard part, though, is exactly the piece what we're talking about right now, is how do we capture to make sure that the way we look at it is captured properly. So here are some additional comments. Does anybody have anything to add to that discussion, possibly?
This is Paul, and I think too, at first I was thinking about the demand aspect of this, but I think you're really right on the mark when you say the demand is probably, because of the diversity of the demand, is probably a difficult to capture all the different water uses by just using the demand on the system, individual systems. Does that make sense?
I think so.
Well, for example, a small watershed in the Albuquerque area probably doesn't need to be as broad as say something up here in the northwest corner that is going to go miles and miles and not really impact a lot of people, but in the long term, it's going to add to the flow of the river that's going to help the individual endangered species or something along those lines. That's what I'm trying to point out, I think.
Yeah, I think that's a really good point. Yeah, and I think like each area is going to be, it's really hard to, like you're saying, that how those differences are. And I think especially in this specific sector is because even if we were only focusing on everything to just agricultural, public water system, and habitat and health industry all within that small watershed in different locations, how do you consider that? And that, I think also to make sure that we're focusing on at least for this sector, just the health of it and how do we measure that resiliency of that. And it is difficult.
Well, I was wondering if you just limit it to the HUC codes, you know, and that really doesn't cover it at all, because if you just look at the Rio Grande, for example, and I'm not sure what code that HUC code that is, but on the other hand, too, if you're looking at something like the Animas River, that HUC code's a lot larger, and it covers more of an area, and it impacts a lot of different uses as well.
Mm-hmm.
So I really think that there are so many different uses for water in New Mexico that it's going to be difficult to fill out this chart.
Mm-hmm. Absolutely. Thank you. Here's a comment. A straightforward measure of resilience for rivers and streams is the indicators of hydrologic alteration method, which requires only USGS stream gauge data. I'll make sure that we consider that for sure. And again, any pieces like that or input, make sure to jump onto our survey, which is on our website. Again, later on in this presentation, we'll have that link information, and anything like that, please kick it our way, because we definitely want to make sure we get that input. Do you have any more details on how you will flesh out what factors will be considered for parameters 5 and 6, which are land use and how landscapes managed? Anna, do you have any comments?
Yeah, I'll just say a couple of things here. I don't, maybe the other folks who worked more on this matrix than I have thoughts on that. I think given sort of the question from Bob Wesley earlier, it's something important for us to think through and figure out how to flesh these out. And if you, Max Henkels, who wrote this comment, have suggestions for us, we certainly would like to hear them, in particular because if we're looking at where are the points in which we can sort of impact our resilience through actionable recommendations, certainly those are going to be where we're looking the strongest. So if folks have thoughts on that. And then I also just maybe want to go back to the conversation with Paul Montoya a minute ago in terms of expectations for 50-year water plan. I don't think, given the scope and time frame for a 50-year water plan, it's not like that plan necessarily is going to look at the entire state and have an in-depth analysis on resilience in these different sectors and in these different climatic regions, say for every watershed. But we certainly want to be able to flag in the 50-year plan where there is the most concern. What are the types of conditions that are the most concerning? And so that's where, we want this matrix to be something that the public or various water users in the different sectors would look to and sort of think through in terms of their work or their local communities. But then in terms of and provide us input that hopefully we can capture in the plan. But in terms of the plan itself, as much as we would like to do an in-depth assessment of resilience in all these sectors across the state, given the time frame, we probably won't be doing that, but we certainly will be using these discussions and our own analysis to reflect back in the 50-year plan where there is the greatest concern, right? So hopefully that's a little bit helpful there. And then back to Max's question about parameters 5 and 6, I wondered if, if John, if you have thoughts, or if anyone else on today has comments on how those should be fleshed out, we certainly would love to hear it. So I would just say, if everyone here, we're going to enlist all of you to be thinking about this, especially because, and provide us input, especially because it does sort of affect what we can do about the situation, right?
Absolutely. Let me read some more comments. Agricultural runoff particularly increases stream salinity is a continuing concern as you go downstream. Pity the poor folks in Texas. How is hydrology affected by wind, erosion, the microchannelization, dust on snow affecting runoff, etc.?
And then maybe also jump to the next one from Toner, which is related.
Okay. I sent a question comment regarding wind erosion and effects on land drainage and dust on snow runoff. Also, can snow reach the ground through overstocked forests? That affects hydrology as well from a water capture perspective.
Any thoughts from participants on those comments?
I'll add on to that. This is Toner again. I wonder if it might be it might be relevant to include soil health as a parameter, given soil's role. I mean, we're talking about losing it to erosion, but it's also important in moisture retention and supporting vegetation communities, which reduce erosion themselves.
Absolutely, and that was a comment, I mean, for slightly related but different purposes maybe in our webinar last week on agriculture, and it just made me, there's lots, this is why we need all of you here, because we in our water world tend to just think about water, and soil is so critical and plays such a key part in water as well. So it's helpful to have everyone thinking like this, and that makes sense to me, Toner.
Some other comments and questions. Current flow regime, perennial, ephemeral, intermediate, should be considered in terms of future low versus high resilience. Interesting, that's true. Can we discuss watershed size? Do you have a map that would be used? I believe I think we discussed this earlier. Grace on the forest action plan kind of has that again. That's going to vary between things. So let's see. Parameters should be measurable points. The parameters listed here are general descriptions, but not actually parameters to measure against. There may be more parameters, but they would be overarching many of these areas.
Thanks, Jennifer. I think these matrices have evolved over time in some ways, from something that could be easily scored to something where there's a lot of gradation, and that's where this one has sort of this relative lower resilience versus. But I think the terminology is important for us to get right, because otherwise it can create some confusion. So certainly something to think about.
How these data sources are queued and aid for use in this analysis is another critical element to flesh out.
Absolutely. And so, Amy Lewis did a lot of work collecting data for the public water systems matrix, and we had quite a bit of discussion about, if you're using some data to get a resilient score in this matrix, then there's always a question about, well, how sound is that data? So yeah, point well taken, Jennifer. Thank you.
And maybe have it in sectors and then parameters within that sector. Some will have a parameter to measure resiliency in multiple sectors. That may be really helpful. And I believe we have a lot of that in a lot of the, with water availability and water diversity, that's in majority of these different sectors. And that might be a way to consider it here also. And but that comment would be a good one as you go through the surveys, and you'll see the different matrices. as you go through them is to consider that and maybe hit on where we could connect those same parameters. Here's another one. I believe this was talked about earlier, but it's a good question. Does it make sense to include soil health as a parameter, given soil's role in retaining moisture and supporting vegetation communities? I think that even the soil erosivity, connecting that maybe with soil health would be a good piece on that. Something to consider. Hannah?
Sure, I agree.
John, I added, maybe it could be in the riparian status, I don't know. There's a lot of information on wetlands and moist soil units that are pretty critical for rare plants and, bugs and all kinds of stuff. And there may be data that actually could, it seems like that could be highly impacted by climate change. And then I was also wondering about just like, I saw that map about, kind of reservoirs or lakes or something that, could be under stress. Are there concerns from the, community, not just on streams, but just open water, ponds and lakes and, the sorts of things that maybe birds need for migration that aren't necessarily connected to a stream. We have a lot of springs, and if that connection, groundwater tables fall because of climate change, you're gonna not have any kind of water sources that you may not consider a stream because they kind of disappear pretty quickly. But I don't know how much information there is available on that, but possibly there's some in some places that might. I just don't want to lose it just because we're only looking at stream conditions.
Mm-hmm. I think that was the whole point of the concept of a watershed, because you have springs and in lakes in there, and reservoirs, and how to touch on that, because even to me a riparian isn't just something that's around a stream. You have riparian zones around lakes and springs, and so how do you reflect on that? It's hard to touch on though, how to consider that concept, you know what I mean, to bring something to show them all the lakes in the state, how healthy the riparian is on them. Most is touching on streams themselves, but that is something that is something to consider along lakes and springs and everything.
Yeah, I know NMED does have a wetlands program that maybe we could look at and just see if there's something there that could fit in with just, how, what's the potential for different watersheds to, lose more, are the wetlands in further danger from climate change?
Yeah,
but
absolutely.
I mean, I think you could put it in the riparian zone. It's just, again, then it starts getting large, but I think it's okay. It's just.
This is Paul again. And from the last comments there, I was just thinking about the change in vegetation due to climate change. If things are going to become more arid, then maybe we're not going to be growing rice anymore. We might be growing something else that would take less water. That's kind of a broad statement, but it's particularly in municipal areas, probably not going to be growing bluegrass, but maybe some other kind of grass in yards and stuff like that, but that also applies to the whole landscape as well. I've been reading some stuff about how the trees are changing altitude because of the dry climate now and the changing climate and that sort of thing. So I think one of the things that needs to be emphasized is that we expect vegetation to change moderately as time goes through this climate change period.
Mhm.
Have you guys covered that in your table here?
I did think we were trying to touch on that in the forest structure composition. Diversity of vegetation types, fuel structures and disturbance, diverse species and drought tolerant populations. Maybe it doesn't touch on the well, and then the lower uniform homogeneous, vulnerable to threshold type disturbance.
Yeah, we have a lot of areas in New Mexico that are semi-arid to arid, and you don't see a lot of trees in those particular areas.
Mhm.
So more grasslands and that sort of thing. So I think this hits it pretty well, but that
It
kind
might
of,
be, yeah, maybe in put just forest structure, but grassland and forest structure. So it, kind of incorporates that concept of, that diversity of vegetation types, but not just to
right.
consider trees, but grasslands too. And
Mhm.
Hey, John, this is Rolf. I just was able to join. Wouldn't the land use parameter of this too kind of go in there? I'm just wondering, how to incorporate it, because I agree it probably would go in forest structure, but that always seems to me to be the upland forest piece, and it seems like the land use piece includes forest, but also all the other areas.
And that one on how landscapes are managed as well. We don't want the ag people to necessarily go out and, if they could plant something that would be economical to them, is that what we want to change, or is that what we're willing to change? And what I'm thinking about tier 2 is maybe like the pecan industry in the southern part of New Mexico. Is that going to be changing, or how's that going to work under climate change?
Right, and again, Paul, that's where it's so easy in these sectors to sort of start talking about different sectors. But I think that you're making a good point here, and certainly something for us to consider. Looking at the time, we only have about 5 minutes left. There's still quite a few good comments or questions in the question box. But I want to make sure that we also get to just the last few slides. So I don't know, maybe, yeah.
Most of these are comments, so I'm going to read them off. Please take them in. Again, most of these are comments, but we'll touch on them again in a few minutes when we're at the end of the presentation. But one is, please add riparian connectivity to riparian status category number 4. Species are a main user of habitats. We're going to see more endangered species. Maybe the matrix should address species resilience somehow. Thank you for all your effort and detail put on this. Great information. Will be a good multidisciplinary tool in the near future. There is a need to look at species endemic to springs cienagas. These are not stream influence, but groundwater influence. NMED has data on this. NMED surface, this is another comment, but it touches on NMED. NMED Surface Water Quality Bureau Watershed Protection section has a rapid assessment methodology, RAM, that may be helpful. It would actually be in both stream condition, which may be more appropriate to call water body condition, riparian status. Thanks for that great input. And then the NMED data for the groundwater influence, Colleen sent the website for that, and thank you on that. And then here's a final one. Possible way to assess resilience: first, assess the effects of depletions in the Middle Rio Grande. Second, establish true collaborative water planning between river basin and aquifer systems. Third, set water storage goals to cope with hard demand and set limits on increasing demand. Look at industrial users and developers bringing their own water through water treatment and reuse requirements. And so those are through those. I will kick it to the next slide. And
hey, John, can I ask you about that last set? This is Rolf again. Those almost seem to be recommended adaptation strategies rather than items that would be added to a resilience matrix, or maybe I'm wrong. I don't know if the person who put that in would like to say a little bit about it, because is it something to put in a resilience matrix to say, do you have these types of things in place? Because if so, that would mean a different level of resilience, or thinking adaptation strategies now and into the future.
Maybe Rolf, I'll just jump in here too. This is Hannah. I think, what I was about to get to in some of the upcoming slides is just wanting people to start thinking about the next phase of this effort, which is recommendations related to adaptation strategies or otherwise. But certainly, I think your question is a good one. And I don't know, was that from Paul?
No, Teresa, she left earlier.
Oh, so she's not here anymore. Okay. All right, well, I think given the time, I would suggest, go ahead, John, and go on to the next slide. I want to just say, though, that this has been a very fruitful discussion. I think we've gotten some very good input, both through the discussion and the question box. Lots for us to consider here. Our goal here is to sort of take this all in and take in the additional comments that we hope to receive over the next 10 days, adjust these, as I mentioned earlier, to release them again sort of mid-October with sort of a final version to include you all to use. But we're really appreciative of having all of these smart folks at the table thinking through these challenging issues. I think it's the only way we're going to confront the challenges ahead. So I just want to thank everybody so much for the thoughtful discussion that we had. And sort of we parked ourselves on that matrix because it was important for us to look at it. But I think these questions on this slide is sort of what we were trying to get at with the presentation today. And then, John, do you want to go to the next slide? So we just had our discussion. As I said, it was better to do that looking at the slide, but there will be an online survey associated with this specific resilience assessment related to watersheds and habitat. We very much encourage you all to mull this over further. This presentation will also be posted on our website, including the matrix we were just looking at. If you can think about it more and provide us input, we're asking for that input in a fairly tight time frame. So the survey will be open through October 8th. We realize that's only about 10 days, but it's because of the time frame that we're on. We will take all of that in, digest it, and incorporate it into the final version that we release mid-October. And I also just want to again thank the folks at MNERD and NMED for very thoughtful input in advance of today's presentation. We'll circle back with those folks too, based on what we hear through October 8th. And next slide, John. So this, you can't click on this on your screen right now, but when this presentation is posted online, you'll be able to click on it there, but also you should be able to navigate to the survey on our website. We welcome your input very much on this assessment in particular, but the entire 50-year water plan effort in general. And also, as I said a moment ago, we certainly encourage you all to be starting thinking too about adaptation strategies and where we get the biggest bang for our buck in terms of recommendations for this 50-year plan and how to spark off next steps coming out of this process. And is this the last slide, John?
No, there's one more. Just where to go for everything.
Great. Thank you. So yeah, indeed, you know, input on this process as a whole is very much welcomed. Some of you have consistently participated in a number of these webinars. We thank you for that. We encourage you to spread the word. They are recorded and posted on the website, so others who missed them will get a chance to check them out. And I think with that, I don't know if Rolf or John, do you have other comments before we close?
Just to make sure, if you submitted even questions with data sets, please do the same on our survey piece, because then we're able to incorporate it with all the input through that too. Again, the survey piece really allows you to elaborate also on your points and ideas on this. So please jump on there, participate. Again, it's on the main page for the 50-year water plan and the public input page. And then there's even a comment page for additional if you couldn't cover it all in the survey. So please participate. It will really help.
And Hannah and John, I just want to say thank you to both of you and then everybody that participated and all the different parties that helped in developing this presentation with the additional information that went into it. There's a lot of great work that's gone on in other parts of the state, and very happy to be able to pull that in here and use it for this resilience assessment survey. Last thing, again, just to remind everybody, what we're looking for here today is the way to best answer or ask questions about resilience so we can assess it and get input from stakeholders about their resilience and the ways that they seek to close gaps in resilience, because that's what we're going to be learning from. Today is helping to set that up. The surveys are coming soon in mid-October. So thank you all.
Perfect. Thanks, Rolf and John, and take care, everybody.
We will see you all tomorrow. We do have a presentation on industry, commercial, mining, and power. I hope you all participate, 2 p.m. Same concept, and we'll see you all there.
Funded.